Okay, so when we start talking about classifying polynomials, this is really how we talk about them. So the first thing is the number of terms. And this is one that most of you probably remember. So the first one we'll talk about is the monomial. And of course mono, and that means one. So that's one term, like, for example, 3x or 2 or 5xyz squared. So one term. There's no pluses or minuses separating anything else in there. The next one is a binomial. And a binomial, of course, has two terms. Again, this telling us the 2. And this would be something like, 2x plus 4. So 2x is a term, 4 is a term. So there's our binomial. The next one is the trinomial, which is, of course, 3 terms. So we would be looking at 4x squared plus 5x minus 7 as a good example of a trinomial, and of course, tri, meaning the 3. And then the last one, somehow there we go, tri. The last one that we'll talk about is the polynomial. And that's a generic term, and that really is just going to cover anything 4 or more terms in addition to that general talking about polynomials. So as soon as it gets above 3 terms, we just call it a polynomial. You will hear me call polynomials with 4 terms. I'll just call them 4-term polynomials because they are special and we do want to make sure we note it, but there is no special name for that. The next way we classify polynomials is based on set, and this goes back to the same idea of when we talked about sets quite some time ago. And when we talked about sets, we knew that there are small sets, and then there are sets that include smaller sets. The real numbers include the rational and the irrational, and so on and so forth. When we start talking about sets, we start talking about if you have something like 3x minus the square root of 7, and I wanted to classify this based on set, I would look at the numbers, the coefficients. So here I would look at this 3, and here I would look at the square root of 7. And I look at the smallest set that both of those go into. Well, 3 is obviously a natural number. The square root of 7 is irrational. So I have to find the smallest set that both of those go into. So the smallest set both go into is the set of reals. If I have something like negative 5x squared minus 1/3, again, I look at this and say, all right, well, I've got negative 5, so that's the set of integers. I've got negative 1/3. Well, 1/3, that's in the set of rational numbers. The set of rational numbers includes the integers. So the smallest set that includes both of those is the set of rational numbers. And that's how we figure that out. We just look at each thing individually, and then the smallest set that all of them fit into. The last sort of classification we have to worry about is the degree on the polynomial. And this is something that we use a lot, somewhat in this class, but certainly as we go further and further, much more. So when we start talking about the degree, all we're really talking about is the highest exponent when it's the same variable. So if I have something like x to the 4th minus 7x squared plus 2x, all I have to do is look for the highest exponent. In this case, it's 4. That makes it a 4th degree polynomial. And most of the time, these are pretty straightforward, and most people find these pretty easy because all we're looking for is the highest variable. Now, it doesn't matter what the variable is. Y to the 7th minus y to the 10th plus y to the 3rd. I don't have this in proper form, but I did that on purpose. So I just want you to look at it and say, where is the highest exponent, and of course it's 10, so this is a 10th degree, and that's literally all it is. Now, the only time that things get a little bit interesting with this are when we've got polynomials with more than one variable. So here's an example. When you've got a polynomial with more than one variable, you've got to do a little bit more work. What's happening on the degree, the actual thought process is, how many variable factors do I have? So we have to really use that process when we've got a polynomial with more than one variable. How many variable factors? So the x has 2. The y has a 1 coefficient, so there's one variable factor there. And the z has a 1 coefficient, so that has a 1 also. So basically, I'm just adding up those exponents. When I add them up, I get a 4. That says I'm multiplying x times y times z. So 4 variable factors. It doesn't matter in this case that they're not the same. So then we go to the second term here, and we see that we've got a 3 on the x and we've got a 2 on the y. So that is 5. And really, remember again, that's x times x times x times y. So I've got 5 variable factors that I'm multiplying together in that term. Go to the next one. Here is x to the first, so 1, and then y to the third, so that's 4. Same idea, x times y times y times y. Here's just x times y, so that's 2 variable factors. Here, there's nothing fancy going on. There's 3 variable factors. Here again, you just have to remember there's a 1 there, so 1 variable factor. Again, though, we go back to the idea of we just go back and look for the highest one. So the highest one is 5. So this polynomial is a 5th degree polynomial.